Okay, now we are going to continue our discussion on plane of symmetry. Question number 3. Copy and draw the following figures. For each of the following figures, draw two planes of symmetry and one axis of rotational symmetry. I'll try to do both the things in all the shapes. The first shape is a cylinder, and this is the answer to this question. They have drawn both the planes of symmetry and the axis of rotational symmetry. This is again the cylinder, and I have mentioned in the previous video the axis of rotational symmetry will enter the center of the bottom till the center of the top, and the axis of symmetry would actually look like this, and it will give you an order of rotational symmetry as infinity. But when it comes to the plane of symmetry, so obviously you will have to place a plane inside the cylinder. Obviously I cannot do that, so the plane of symmetry will be somewhere around here and it will be circular. I'll try to make some planes and put them inside in the other shapes. So this is what the plane of symmetry would look like. It will be from the top till the bottom in a circular form like this, and the other plane of symmetry would actually be like this, going from this side, then this, and then here, and then bottom. Okay, so the plane of symmetry would be something like this, and this circular shape is side. So plane of symmetry would be something like this. I'll try and show it to you. Yes, something like this. Okay, when you face it, it looks like this, and this is how it will be. I hope it is clear. Okay, the answer is here. You can have a look how it is drawn. This is the one, the vertical one, and the circular one is horizontal. Then the next shape is a right pyramid with a rectangular base, and when it comes to a right pyramid, this is what a pyramid looks like. We have discussed what a pyramid looks like. This is a pyramid and its bottom is definitely a rectangle, as you can see. So you have to first of all draw the planes of symmetry. The plane of symmetry, the one plane of symmetry will be a triangular shape going from this, going from this side to the other side, like something like this. Okay, and the other plane of symmetry would be from this side, whole bottom, and covering this. So this is how it will almost look like. The front side almost it will look like this. So there will be two planes of symmetry. One will be like this in this form, and the other will be in this form, and again the axis of rotation will be from the center of the bottom till the apex, and it will give you an order of rotational symmetry as 1 and 2 only, not more than that. Then comes this shape, a right prism. It's a prism now, it's not a pyramid anymore. A right prism with an equilateral triangle as the base. This is a right prism and its bottoms are triangles, equilateral triangles, and you have to draw planes of symmetry. One plane of symmetry will be like this, half of this triangle, okay, like this, and it will be drawn from this side to this side and throughout here. This is what the plane of symmetry will look like. It will be going all along till the back side. This will be the first plane of symmetry. The second plane of symmetry will be here, and it will be in the middle, in the center. It will be here in the middle. It will be same as this triangle and will be placed in the center at this point, you can see the answer over here. They have placed the prism in this form, and these are the two planes of symmetry. When it comes to axis of symmetry, again the axis of symmetry will only be one, going from the center of this side to the center of this. So this will be the only axis of symmetry from the bottom till the top, and when I rotate it, so the order of rotational symmetry will only be 3. This is first, okay, this is 1, this is 2, this is 3, or maybe you can understand it from this side a little better. 1 and then 2 and then 3. And the next shape is again a cone. I have discussed what a cone looks like. In a cone there can be infinite planes of symmetry in the triangular form, and they will be like this, and they will continue. There will be as many planes as possible. There will be infinite planes of symmetry, although there will only be one axis of rotation with an infinite order of rotational symmetry. Then comes a regular tetrahedron, and I hope you can see the answer. This is the question, this is the answer to the question. And when it comes to a regular tetrahedron, this is how it looks like. There are this is 1, 2, 3, and the bottom. There are 4 triangular surfaces in a regular tetrahedron, and they all are equilateral. All the shapes are equilateral to each other. There can only be one axis of rotation, like I discussed before, entering from the center of the bottom and going till the top. And what will be the order of rotational symmetry because of this axis of symmetry? 1, 2, 3, and you can continue doing it. I did it from this bottom, you can enter it from here. When you enter one axis of symmetry from this side, that will also present 3 as the order of rotational symmetry. So the order of rotational symmetry for each axis of symmetry will be 3. There can possibly be 3 axes of rotational symmetry, 3 axes of rotation, one entering from one triangle to the apex, one entering from this side, and at a different incident you might enter one from this side, and then from this. So there can possibly be 4 axes of rotation, but you can only insert one at a time and then rotate it. The order of rotation symmetry will be 3 in that case. And the planes of symmetry, if I want to draw 2, so this will be 1 entering from the middle, center of the triangle that we are facing, and bottom, and then up till here it will touch the vertex. So you can say each plane of symmetry will touch this edge to the median of the opposite side. I'm calling it median, to the center of the opposite triangle. Okay? So from this side to the middle, and in this way we can insert 4 planes of symmetry, but we are only asked to draw 2, so we will only be drawing 2, but there can possibly be 4 planes of symmetry in this case. Then comes the last part, a regular right hexagonal prism. This is a hexagonal prism. In a prism there have to be 2 congruent surfaces opposite to each other, and this is a hexagonal prism. When it comes to plane of symmetry, the planes of symmetry can be from the center of this surface to the center of the surface opposite to it, between these two. It will continue to be like this. In this way, from the center of this surface to the center of the surface opposite to it, I can have 3 planes of symmetry, and I can also have planes of symmetry from this edge to the edge opposite to it, something like this, and it will be a surface. So it will be a surface. You can see I can have a plane of symmetry from this vertex to this, and from the midpoint of this side to the midpoint of the other side. So I'll have three planes of symmetry in this form, from midpoint of one side to the midpoint of the other side, and I can have three more planes of symmetry from one vertex to the opposite vertex. In this way there can be total 6 planes of symmetry, but I only need to draw any 2. For axis of rotation, there will again only be one axis of rotation from the center of the bottom till the center of the top, and that will give me 6 as an order of rotational symmetry. That's it for now. In the next video I'll upload solution to question number 4, and I hope this time you will be able to see these answers clearly. This is question number 3, first 4 parts, and this is question number 3, next 2 parts. I'll discuss question number 4 and the other questions in the next video.